In this lesson, you will complete the square to write perfect square trinomials and will solve quadratic equations by completing the square. In Chapter 9, you are going to have a lot of tools in your toolbox to find the roots or find the solutions of a parabola, of a quadratic function. And you've been working with graphing the last two lessons. So this is a new tool. It's called completing the square. Here's where it came from. Al-Khwarizmi was born in Baghdad. He's from Iraq, and he's one of the foremost mathematicians of all time. He is the person who discovered completing the square. And what he did is he took this algebraic equation, which we know is a quadratic function, and he said, what I can do to solve this, and he used pictures to kind of help him out. If I have that x squared plus that 8x's, what I have then is this square that has missing the 4 corners. So if I could just put in ones to fill those 4 corners, I could then complete the square. So it's a visual. The square is the visual, but the function is completing the square. And so the completing the square, if you count these up, would be adding 16. So I would have x squared plus 8x plus 16, and then I would add 16 to this side. So that would be 35, 45, 51, and then we could go from there and solve. So first of all, what is completing the square? It is to add the constant term to a binomial of the form x squared plus bx so that the resulting trinomial is a perfect square. So what would I add to this to get a perfect square? Well, you could build the tiles like he did. Here's your x squared, here's your 4x, and then what do I need to add to complete the square? Or you can use our equation, and I'll put this in your notes, and this is what we'll use most often. Find half of b and then square it, and that's called completing the square. So if my equation is x squared plus 4x, if I want to know what this is, I take half of 4, because that's the b term. Half of 4 is 2, and then I square it. So c in this case would have to be 4. X squared plus 8x, what would c have to be? Half of b, so that would be 4, squared. So c would, in this case, would have to be 16. So you take half of the middle term and square it. Try that example in your notes. Now we can solve an equation by completing the square. So there are 2 different methods that you can use. You can subtract 19 first, if you wanted to, and make this x squared minus 6x minus 7 equals 0, and then go from there. So that would be half of negative 3, so that would be a positive 9, so you would add 9 to both sides. Or you could just go to your original equation, x squared minus 6x plus 12 equals 19. And what you could do is you could say, okay, I have to make this 9. So what could I do to make this 9? You could subtract 3. So then we have x squared minus 6x plus 9 equals, that'd be 16. I don't care which way you go subtracting. I really don't care. The nice thing about this method is it only took 1 step. All I had to do was subtract 3 to make this the 9 that I want. So it's a little bit easier because it's fewer steps. Now we're going to go ahead and factor. So this is x minus 3 quantity squared equals 16. Now we're going to use square root property. Remember that from chapter 8. We square root both sides, and we have x minus 3 equals 4, x minus 3 equals negative 4, because square root of 16 is either 4 or negative 4. So we add 3, and we get x equals 7. We add 3 here, and we get x equals negative 1. So this is a double root, or 2 roots, and they are negative 1 and 7. Now, if you wanted to graph this, you would see that it crosses at negative 1 and 7. But this is a way, completing the square is a tool to use to find the solutions without having to graph. And it's really nice because once we factor it out, we have our solutions. We didn't even need our calculator to graph. So you try the example in your notes of completing the square. Try to use this method where you find half of b and try to make that c term into that number. Try it now. All right, what do you have if I have an a term that is not equal to 1? Can I still use completing the square? You absolutely can. What we're going to do though is look for a common factor first. And if I factor out a negative 2 from all of these terms, this will just make it a little cleaner for me to balance here. So this would be x squared. Divide this by negative 2, that's negative 4x. Divide this by negative 2, that's plus 9. So now we want to make this inside a perfect square trinomial. So this is half of negative 4, so that'd be negative 2 squared. I want to make this a 4. And I can do that by subtracting 5. So I have negative 2 parenthesis x squared minus 4x plus 4 equals negative 5. Now I can factor negative 2x minus 2 quantity squared equals negative 5. And I'll see something interesting here. When I do my square root property or divide by negative 2 on both sides, whatever you want to do there, you're going to notice that when I do a radical of a negative, this is not possible. I cannot have a negative inside a radical sign. So this is an example of an empty set. If you wanted to graph it, you would see it's a parabola that's up in the air. This is not going to have solutions. It will not simplify. So you just say empty set and move on. Now I want you to try an example of in your notes where you have to factor out first. So I'm going to give you a coefficient of something other than 1. But I'm going to tell you right now, it's going to work out. It might be decimals, but it's going to work. So try the example in your notes now. All right. We're done.